let's go. Right, so this is module 8 retention point. Module 8, we covered the network layer. Module 9, I think it was the address resolution protocol. Then module 10, basic router configuration, which is more like chapter 2, basic device configuration, where basically we focused on the switch. So I think the core of this checkpoint will be the network layer. You see a lot of IP addressing. Definitely, you will see a lot of address resolution. Right, starting with number 1. Information used by routers to forward the data packets towards its destination. Keywords. When we were doing 4 to 7, I think we saw a lot of frames. It's because we're dealing with layer 2. This is system layer 3. You're going to be seeing a lot of packets. It's very important differentiating those PDUs, because you have at each layer, which protocol data units do we have? So at the physical layer, we have the bits. Then we go to the frame layer 2, packet layer 3, segments layer 4, then 5, 6, 7. That's that. Where's my pen? 5, 6, 7, that's that. Right, let me try to find, where did I find my pen? Comment. This one. Right, so number 1, answers. Which information is used by routers to forward a data packet towards its destination? The source? No. We can't use the source to forward to the destination. What else do we have? Destination IP. Voila. We can't use this one. We can't use this one. I think B makes sense. Number 2, a computer has to send a packet to a destination also the same line. How will the packet be sent? Right. A packet can either be sent locally, which is the same line like in this question, or it can be sent remotely. If it is being sent locally, it can be sent directly to the destination device. If it is being sent remotely, it will have to go via the default gateway. I think that's key to getting an answer to this question. TPM answers, the packet will be sent to the default gateway first. No, it's local. If it is local, there is no need for it to go to the default gateway. The packet will be sent only to the default gateway. No. B and C. The packet will be sent to the default gateway. No. Evidently, our answer is B for this one. Right, I think, like I said, 8, 9, 10, the checkpoint is very easy. It's very easy understanding the layer 3 of the OSI module. I think the data link layer, the Ethernet, it's a bit complex understanding those two modules. Right, a router receives a packet from the gigabit, okay, gigabit 00 interface, and determines that the packet needs to be forwarded to the 01 interface. What will be the router? What will the router do next? Right here, I just want for you to understand what gigabit means. You will see fast Ethernet as well. What does that mean? What's the difference between gigabit? What is the difference between a gigabit interface and a fast Ethernet interface? The only difference is in terms of uh, speed of the port. A giga Ethernet port can go up to 1 gig, 10 gig, 40 gig. It can push up to those speeds. But the maximum for fast Ethernet is 100 megabytes. So if you see gigabit, it means more speeds, definitely more capacity if you are going to have a medium which has a lot of capacity. Therefore, you'll be able to push more speeds on that specific medium. You see, if I'm connecting a network and I have my PC, right? I have my PC, then I have my switch. My pen is working perfect today. I have another PC, then I have a router here. You see, when you're designing a network, most of the times these links here will be fast Ethernet, 100 megabytes, right? 100 megabytes per second. That's a lot of speed slash capacity for just one PC. But if you have, let's say you have multiple PCs here, you have 10, and every one of them is pushing traffic, and all the traffic is going via this link. What happens if you have a fast Ethernet link connecting the switch and the router? What happens? So we have 10 PCs, each of those PCs pushing at most 100 megabytes per second, and the connection between our switch and the router is fast Ethernet port. What happens in that network? There's a problem there. Waiting for the answer from you. What do you think happens to the network? Any takers? I said fast is 100 MB, gig is 1 gig. It slows down, congestion. It slows down. Why? Because you're trying to push it at least 1,000 megabytes here, which is 1 gig. But the capacity of your link is only 100 megabytes. So your traffic will get congested, the network slows down. So you see most likely here we're going to have a Giga Ethernet connecting these two ports. Okay, tips, designing a network. Right, so going to our question number 3, a router receives a packet from the Gigabit Ethernet interface and determines the packet needs to be forwarded to another 01 interface. What will the router do next? Okay, answers. What do we have here? We have 2 routers. The router is received on the Giga Ethernet. This is our router. So this is 00. This is 01. A packet is received, Kunok. It needs to go out, Kunok. What happens there? Right, route A. Route the packet out the gigabit interface. Route. Okay. Let's eliminate a couple of answers first. Not so sure yet. Let's eliminate a couple of answers. Create a new layer 2 Ethernet frame to be sent to the destination. Okay. Look into the ARP cache to determine the destination IP address. All right, this one is a bit tricky. I'll need some answers to explain their answers. Look into the routing table to determine if the destination network is in the routing table. This one is a bit tricky. Explain your answer, Lloyd. Why A?
Okay, it was A in the sense that pandaverenga pese handinabvira ndamboverenga pekuti inonzi the router actually has to create a new layer 2 ethernet frame, though plus another thing ndezvekuti mainterfaces ayo explained kuti kana patongoita connection mainterfaces are two, there are two different networks.
Yes,
Saka pakutoda routing inenge yatoo routing iyoyo
but zvese zviri
because
kuitika
yapinda from
ma-interface ari pasame router ka different network, yes, but ma-interface ari pasame router. If
okay, yeah, saka
if we had a situation like this, right, where we are sending a packet kubva panapa kuenda apa, we would definitely need routing there because we're moving a packet from one network to another network, different routers. Does it make sense? Panapa a packet
yeah,
in the same device.
yeah, saka this is a learning moment for me.
Vamwe participate. Chip in things. Chip in things. I'm waiting for some answers. Whilst I also think, what is happening here? Look into the ARP cache to determine the destination IP address. Right? Think in terms of what happens in terms of encapsulation, de-encapsulation. When a router receives a packet, what happens? In terms of encapsulation, de-encapsulation. What happens when a router receives a packet? Right, we have packet redo rasendwa rasvika rinosvikira panapa in the physical layer, right? Rasvika in the physical layer via this link right here. Rinoendeswa layer number 2. That's the encapsulation. Rinoendeswa layer number 2. If the MAC address matches that of the interface, rinoendeswa layer 3. If it matches, then takutanga kuita re-encapsulation. Pakuita re-encapsulation, that packet is moved to this interface. It is moved to that interface via layer 2 addressing, not layer 3. It is moved via layer 2 addressing. Because what is happening here, let's create a network in category. Just a minute. Can I share something? Right, let's have a proper network. Let's have our PC. Let us go through the process of encapsulation, de-encapsulation, and all. Let's have a switch because I think that's the key to getting an answer here. Let's have a router. Let's have a switch. Let's have another PC2, PC1. Right. Ndambopinda encapsulation, de-encapsulation, Bichan. I want someone to take over. What happens when PC1 wants to, this is the source, like, right, let's use source IP because we're talking, we're communicating remotely here. So this is the destination IP. Right, here we have the source MAC. Here, we don't know the MAC of this destination network. Here we have the default gateway. Right? Let's imitate the question that we were given. Here we have 01. Exactly like this. What is happening between PC1 and the 00 interface in terms of encapsulation and de-encapsulation? Can anyone take us through that process? Kubva PC1 tosvika paswitch. Switch rovhura frame, reincapsulata, roforwarda, richiendesa. What's the process? What is happening there? Do you get the question I'm asking? Maybe we can start there.
In Nango, I think I get it and so I'm just giving a chance how was meaning. Regardless of what thing answer I'm going correct or wrong, I'll just say it anyway. But I can't
You have to say it. You have to say it. That's how we learn. Can you briefly go through the process of encapsulation, de-encapsulation as data is being sent from? Let's start with PC kusvika pa-default gateway router.
Okay. From my understanding, at least so far,
Mhm.
there's what when PC1 wants to communicate with PC2 on a different network,
Yeah.
um, it sends a, that's a frame and physical layer and
Uh, frame is
there's
frame is the layer number 2.
learn about it. It sends my bit and
Yeah.
from the from the Ethernet layer. And yobva yaencapsulata yopfekedzwa softmark yePC1 nedestination MAC address. But destination MAC address apa panenya kuti asi within our same network, our default gateway becomes our
Okay.
destination MAC address.
That's point number 1. I want everyone to get. It's a bit all over the place, but point number 1. If we are communicating remotely, the frame rate ruba pa PC1 up. The destination MAC inenge yakaiswa MAC address default gateway. The destination IP inenge yakaiswa PC number 2. Did you get what I just said? So pa frame redu source mark PC1 pa frame source mark PC1 and destination mark default gateway. Destination IP PC2, source IP PC1. That's for the packet. Right, you can continue.
So
You can continue maybe starting here. Let's say packet redu destination that or not default gateway. Frame redu, right?
right,
Frame redu now rapana.
rapa default gateway,
Yeah.
right? Rapa default gateway apakapa nditika.
Yeah.
It is encapsulated anditika. Rotariswa kunoti the default the destination IP address is it within the network or it's outside. If it's outside, roencapsulate manje rakuchipfeka tosa MAC address yako kunge iri default gateway.
Yeah.
Ndoya
So
kuti
now destination yayishi.
Destination manje yaye I think yaye interface 001.
Interface 01.
Then interface 01 futhi inosvika futhi encapsulator futhi yobva encapsulator futhi
Right.
yakutranslator.
Right. Usati waenda ku-encapsulation yepa interface 01. Watopindura answer yekuti what is happening between chasendwa pa ichi ipacket around the frame. Exactly. Ndo pane answer ipapo. Tikadzoka pa question chitiudza answer to number 3. Go through the answer.
Yatongo qualify.
Exactly. If you look at my answers SR, anotanga anoqualify wachitanga kumataris, but powder kunyatsoziva, like here the process of encapsulation, de-encapsulation, ndo yaikubatsira kuti usvike paanswer chaipo. Because pari trick ipapo, you are sending from this interface to this interface. Hapana maroutes anodikanwa pa because frame ndo riri kusendwa painterface from 00 to 01. Right, so if we are to continue, rasvika panapa frame area right, panoitwa re-encapsulation ndo panotanga the process of ARP, panenge rautwa re-encapsulation. Panovhurwa packet rorakidzwa kunzi packet redu rine destination IPE, what is the source mark, what is the destination mark. Destination mark yadzoka panapa, frame redu raiswa source mark destination mark, with the destination mark of this one and with the source of this interface here. Then re-encapsulation yakuenda palayer 3, destination IP inenge itoripo kudhara, source inenge iri E. The IP source destination haichinji panenge pari kubva from PC1 to PC2. Chinochinja ma-addresses layer 2. So kana yasvika panapa ARP yapedza basa, ndo panozoendeswa packet to the destination here. But the key question is between these two interfaces are, and the answer is B, because chinosendwa apo is the frame. Right. Let's continue. Number 4, which IPv4 address can a host use to ping a loopback interface? What is a loopback interface? Let's start there. Who's in here today? Black Russian, hello, how are you? Unmute. Let's have the discussion. What is a loopback interface? Test packets. All right. I think that's close enough an answer. So a loopback interface is basically a visual interface which is used to test if, for example, if a number of protocols are operational on a device, if TCP is operational mostly, right? So basically how it works, if we have a router, our router, it has its interfaces 01 and 00. Those are physical interfaces, right? We create a visual interface, which is called the loopback interface. So we have a visual interface here that we created. What we use that loopback interface is to send packets to the device which is sending those packets. Basically, router 1, if it wants to send packets to itself, if router 1 wants to send packets to router 1, it uses this interface called the loopback interface. There is no other way a device can send information to itself, packets to itself, unless it is a loopback interface. So if it sends packets to the loopback interface and it gets a response, it means that device is operational. Basically, that's how the loopback interface works. Now, going to my addresses, they use this network. This is the network ID, which is used by the loopback interface. Then an address within that network is D, 127.0.0.1. So this is an example of a loopback interface, D. Okay. Loopback interface. Okay. I think that's good enough for this stage. Nanda questions of router IDs, but not necessary. So this one, the answer is D. That's a loopback interface. Right. Number 5, a computer can access devices on the same network, but cannot access devices on other networks. What is the probable cause of this problem? So we have a computer which can access devices on the local area network, but cannot access devices on the other network. That's a very common problem, very easy to see. D, the computer is an invalid default gateway, most likely. Let me see if I can eliminate some answers. The cable is not correctly connected. No. Computer has an invalid IP address. No. Which computer? This one. If it's communicating locally, then everything is proper. The computer is an incorrect. Yeah, it's definitely D. If the default gateway is incorrectly configured, then you are going to have problems. Your network will not be able to communicate remotely. Right. Number 6, which statement describes a feature of IP protocols? IP encapsulation is modified based on network media. IP relies on layer 2 protocols for transmission error control. That's not true. MAC addresses are used during the IP packet encapsulation. This one out. Anyone's answer. If the subnet mask is improperly configured, what happens? It depends. It depends. What does improper mean? But I'll give you an example. Let's do this. Let's create a network. Let's create two networks. Let's have this one. Let's have this network be 192.168.10.0. That's the network. /24, meaning the subnet mask is 22255.0. Right. Kunoku toa neimwe network 192.168.20.0. Same thing. /24 subnet mask is 22255.0. Right. Ukaisa incorrect subnet mask on every device iri muno mulano. Panapa oisa incorrect subnet mask as well. Your network will probably communicate. Will likely communicate. Depending on the IP address iyoyo haizoite conflict here kana yakambopiwa yakasignwa someone else as a public IP address. If not, then you are going to get communication. Especially from simulation tools that you are definitely going to get communication because it just means you've chosen a different network panel from the one that you have been assigned from questions and something like that. So you can communicate. In real life situations, ukashandisa IP address isiriyo, it means unogona kuita conflict because network address yaunenge wakaassignwa ne-service provider unenge wakaisainwa on the basis yekuti it's not been assigned to someone else. So if you're using another network ID, you might be using a network ID that has been assigned to someone else. Then that becomes tricky. However, maybe network yako wango port our IP address one PC rimline of voice subnet mask is a bit different than every other device. It also means device RAM network is real. So communication I do it as well. Communication won't be there because the subnet mask don't define what network a host belongs to. So panning up basic. Are you answered who was that? Black Russian. I think there are quite a number of scenarios which we can go through. The two guys are subnet mask is wrong. What happens? Yes, right. Let's continue. Number 5, we did that one. Number 6, right? Which statement describes a feature of the IP protocol? IP relies on upper layer services to handle situations of missing or out of order packets. Which one is the answer here? IP encapsulation is modified based on the network media. This one is false. Encapsulation, this one is false. I think D. Why D? Why D? That's the question. Encapsulation, we are going down, right? Modified based on network media. Layer number 3 does not care what media we have. Why does it not care? Because we have layer 2, which deals with media access. So layer 3, whatever protocol is there, layer 2 will deal with everything. So that's why A is out. We have B and D. Explain your answers. Either you give me an explanation why D is correct or why B is not correct. IP relies.
There are two possible answers, B and D. But why I chose to go with D was that Nangozoti, the IP in the network layer. I don't know if I'm wrong, but it doesn't. Errors. It relies on other protocols, on other layers. I mean, to check for all of the
Layer
errors.
3 does check some yatakaita manager. Inodhila ma-errors.
Yeah, okay, so it's a learning process. It's a learning moment for me.
Right. IP relies on layer 2 protocols for transmission error control. No, it does not. I'll explain this one. IP relies on upper layer services to handle situation of missing or out of order packets. Right. We have the transport layer. That's the upper layer which is being talked about here. The transport layer is responsible for if you have a missing packet, then no acknowledgement is sent, then that packet will need to be resent. Transport layer. If you have an out of order packet, the transport layer, probably an issue to do with sequencing, is gone south. In the upper layer, the transport layer deals with that. So D is the correct answer here. Okay. Right. Let's move. Number 7. Why is not needed in IPv6? Network address translation. I think it's Pamberi Apple. It should be CCNA 2 or 3, 2. I think CCNA 2. Why is not needed? The reason why is because IPv6 has a lot of addresses. Therefore, there is no need for address translation. Let's find an answer that relates to what I just said. Because IPv6 has an integrated security, there is no need to hide the IPv6 address from the internal networks. B, this one is off. Any host user can get a public address because the number of available is extremely large. Voila. B, that's the answer. This one. Let's look at the other answers to 181 pane. The problems that are induced by NAT applications are solved because IPv6 header improves packet handling by intermediate routers. This is true, but is this the answer? This statement is true, but I don't think that's the answer to the question. A statement really true by question, but does it answer the question? Probably not. End-to-end connectivity problems that are caused by NAT are solved because The number of routes increases with the number of nodes that are connected to the internet. Yeah. Okay. Let's look at number 8. Which parameter does the router use to choose the path to the destination when there are multiple routes? When there are multiple routes, we have cost that are used. Which parameter does the router use to choose the path to the destination when there are multiple routes? Right. We're trying to send a packet. Okay, 1 minute 20. Let me see if I can give an example of what's happening there. Right. So we are trying to send a packet from PC1. Packet ready to upon PC2, but packet richishika pa router is. It can either take this route, let's call it route 1, or it can take this route, let's call it route 2. Which route will this packet choose? Which route will it take, if I can say? What factors affect the choice of the route which is being taken? Because kunokwanisa kuyena kuno rinosvika parauta iri rinosvika apa, or rinokwanisa kuyena apa direct apa rinosvika pa PC2. Let's continue with question number 8. I can see time here to shake up. Log in using the same link.